Welcome to EDU World Space.
Today we will be solving problem 14.22. In this problem, it states that there are two spheres, A and B. A is moving to the right, or the x direction, at 16 feet per second on a frictionless horizontal surface, and B is stationary. When A collides into B, A continues to the right, and B splits into two pieces, which we'll call C and D. Now C moves up at 30 degrees, and D, we do not know the angle at which it moves down. The total distance covered in the x direction is 6.3 feet, and PC reaches that in 0.7 seconds, and D reaches that in 0.9 seconds. Now we are tasked to solve two parts. Firstly, what is the velocity of sphere A after the collision? And secondly, what is the angle at which D moves downwards, and what are the final velocities of piece D and piece C? So I will start off with writing the momentum principle, which we can write as this. Now we can substitute in various givens and remove all the m's because they are all the same. Now, it's important to remember that the momentum principle is applicable in this instance in the x direction. So we want to make sure that each velocity that we're representing in the equation is in the x direction, which is why I denote C and D velocities with an x. Now, we can determine those two values using some geometry that's initially given in the problem. So as previously drawn before, we don't know D's angle, but we do know C's angle, which is 30. So PC travels 6.3 feet in 0.7 seconds, which gives us a x velocity of 9 feet per second. For the y component, because we're given the angle of 30 degrees, we can write it as this. And now VCY, let's keep it to be 5.196 feet per second. Now to find the total velocity, we can use the Pythagorean theorem. Which gives us about 10.39 feet per second. Now for the bottom portion, we can start out the same way. In the 6.3 feet, the D piece travels 0.9 seconds, which gives us 7 feet per second. And that's currently all we know for that one because we don't know the angle. So now we have enough information to plug it back into the momentum equation. So 16 equals, we don't know the velocity of A after the collision, but we do know VCX, which was 9, and VDX, which was 7. That gives us 8. And so now we know that VA prime equals 8 feet per second. So that solves part A. Now, for part B, we know that the angle, again, above was 30 degrees, but we don't know the bottom one. Now, we also know that pieces C and pieces D have the same mass, which means if we did the momentum principle in the y direction, we would get 1/2 m, so that's the mass of C, times its velocity in the y direction, should equal D's velocity in that direction, right? Because they're both, one is moving up and one is moving down in the y direction, and that is after the collision, and those are the only two pieces that have y direction change, which is why those are the only two terms in the equation. But this kind of becomes easy for us because since the masses are the same, those cancel out, which means that in order to conserve momentum, the y component of the velocity for C should equal the y component of velocity for D. So we can now determine the angle because we have piece D's x and y velocities. So if we do the tangent of this and take the inverse tangent of that number right here, we will get theta to equal 36.6 degrees. And so to rewrite the previous values, VC equals 10.39. This was after the Pythagorean theorem. And then VD should be equal to 8.72 feet per second.